Hello everyone, my name is Lindsey and I am a ME student from Goa College of Engineering, and I am here to present my paper entitled as Development of IoT enabled energy saving smart lighting and HVAC system for a building environment, where HVAC stands for heating, ventilation and air conditioning system. The entire project was conducted in the Spindly company, Fathodda, Goa. And my external guide is Sir Mohinish Naik, who is the firmware architect in that company. And my internal guide is Sir Dr. Virani Hassanali, who is the HOD of ETC Department, GEC, Farmagudi, Goa. Coming to the problem statement, in my current office where I have been doing my project, most of the appliances, that is the lights, fans and ACs, are not automatically controlled. That is, the user have to get up from their workspace and turn on and off these appliances. If the employee tends to forget to switch on and off these appliances due to its heavy workload, then it obviously increases the amount of energy consumed and thereby increasing the cost of the company. So the objective of my project is to first design a system that will efficiently automatically control all these appliances, that is the fans, lights and ACs, and thereby decreasing the amount of energy consumed, thereby reducing the cost of the company. So I have done the literature survey on the 8 base papers. The first is the Arduino Uno smart lighting control system. Second is the automatic room light controller that uses a visitor counter. Third is design and implementation of a leader follower smart office lighting control system which is based on IoT. Fourth is design of office intelligent light system using Arduino. Fifth is smart lighting system. Sixth is light intensity controlled seamless highway system. Seventh is the design, implementation and deployment of a smart lighting system for building environment. And the seventh one is a thermo, that is the smart air conditioner controller integrated with temperature and humidity sensors. So I have done a comparison on all these 8 base papers depending on its application field, the method it has used, if it is server based or microcontroller based, the types of sensors used, if it is IoT based or not, energy efficiency and cost has been mentioned. So we can see in the comparison table that all the base papers are used for different applications, like some are used for living room, some are used on street, some are used for indoor spaces. And the methods also vary depending on paper. Some use the closed loop controller, some use the environmental strategies, others use the brightness of the LED, etc. Some are server based, some are microcontroller based. The different types of sensors used, like the light sensor, PIR, IoT based or not, energy efficiency if it is high, medium or low, or if it is not applicable, and obviously the cost if it is low or high. So my proposed system, the application is based in Office, and the method used is it turns to low light mode whenever there is no one present in the room, and it turns to highlight mode when someone is present in the room. It uses the microcontroller, that is the Arduino. It uses two sensors, PIR sensors, for the entry and exit, and I have also used a humidity sensor. It is IoT enabled. Yes, the energy efficiency is high and the cost is also low. This is the flowchart of the project. Once the system establishes a connection, it will check if the connection is continuous. If not, it will retry and go back to the loop. If yes, it will check if the PIR has received a trigger signal. So it will check what type of trigger signal it has received. Either it is from the entry PIR or at the exit PIR. So if it is at the entry PIR sensor, that it is showing that someone is passing by. That means the counter is increased by 1. If the trigger signal is from the exit PIR, then it shows that someone has left the room and the counter is decreased by 1. If there are no trigger signals, it shows that no one has passed and the counter value remains the same. So after all this, the counter value is checked. Only when the counter is 0, it shows that if yes it is 0, it shows that the space is empty, that is no one is present in the room. That is the time I have to turn off all the appliances, that is I am going in my low light mode. If the counter is not 0, that means someone is still present in the room and the uh, room continues to be in the high light mode. This section of the flowchart takes care of the IoT enabling section. This is the block diagram of the system. I have my Arduino Uno, which is my microcontroller, the PIR sensor and humidity sensor, of course the power supply module. The communication module has been used to make it IoT enabled. A relay network is used to which my outputs are connected, that is my bulb and the motor. I have used an air conditioner and a IR LED transmitter in order to get the raw data from it. So this is my block diagram of the proposed system. So the working is generally, as I said, when someone enters the room, all the appliances, that is my AC and my lights, are turned on. And when the person leaves the room, they are turned off. And the same information is sent to the Adafruit IO, that is my IoT software, where all the switches can be controlled by the user according to its needs. So these are the components that I used. First is my microcontroller, the PIR sensor, temperature sensor, and the relay module. Arduino Uno is the microcontroller used. It is an open source. It has 14 IO pins. It operates at a 5-volt voltage and it uses a pull-up resistor of 20 to 50 kilo ohms. Next is my PIR passive infrared sensor. The first pin 1 is my drain terminal, pin 2 is my source terminal, and pin 3 is my ground. It senses motion. They are small, inexpensive, they are low powered and easy to use, and they don't wear out easily. Third is my temperature sensor. I have used the DHT11 sensor, which has a capacitive humidity sensing element. The temperature range is 0 to 50 degrees Celsius with accuracy of 2 degrees, and the humidity range is 20 to 80% with accuracy of 5%. The relay module used is the normal one, which acts as a electrical switch. Now, coming to the software implementation, the entire simulation of this project was done in Proteus Design Suite version 8.0, where C++ language was used and it was compiled in Arduino IDE. So the entire testing, debugging of the system was done in this software Proteus. The simulations were conducted in 5 parts. First is interfacing PIR sensor to Arduino. Second is interfacing temperature sensor to Arduino. Third, interfacing relay to the Arduino. Fourth is interfacing temperature sensor and the motor of the fan to the Arduino. And fifth is final interfacing of the entire all the above 4. So the general idea for this simulation is, first I will paste all the zip file of first I will download all the libraries of the sensors which I am going to use and then paste the zip file in the Arduino. Then after I do that, I paste the code, I run the code, extract the project file, copy the hex file and paste it to the project file of the Arduino Uno. So this is the general idea that for all the simulations I will be using these steps. So my first simulation is interfacing PIR sensor to the Arduino. Now, here in this one, the first one, pin 1 is my ground, where ground is given. Pin 2 is the VCC, where power is given. And pin 3 is my output, which is connected to pin 13. Yes, pin 13 of the Arduino. We can see that at the Arduino, I have connected a LED and a resistor of 10 kilo ohms. And at the test pin of the sensor, I have used a logic state. So whenever the logic state turns from 0 to 1, it will be indicated by this red LED. I have also used a virtual terminal as seen on the workspace in order for the user to interact with the system, in order to receive the information and give the information. So this is the circuitry. The code is such that in the beginning I have given a 10 seconds delay in order to calibrate the sensor, and after the end of the 10 seconds, the virtual terminal will print that calibrating is done and the sensor is now active. So only when the logic state is 0, it will show that there is no motion. And when the logic state is 1, it will show that motion is detected and it will print at what time the motion is detected. If there is no movement for less than 5 seconds, LED will turn off. If there is no movement for more than 5 seconds, then the virtual terminal will print that the motion has ended at so and so seconds. So this is my output. I have toggled the state from 0 to 1, and same has been indicated by the rail LED by turning it on, and the virtual terminal has also printed that motion is detected at 15 seconds. So this shows the successful working of the PIR sensor with the Arduino. Second is interfacing temperature sensor to Arduino. So I have the temperature sensor where pin 1 is VDD given the external DC voltage. Pin 2 is the data which is connected to pin 2 of the Arduino, and pin 4 is my ground which is given the ground. Similarly, I have the virtual terminal as earlier. So here in this case, I will be increasing and decreasing the temperatures using the sensors. So the it has the accuracy of 0 to 50 degrees Celsius as I mentioned earlier in the component parts, and the humidity is 20 to 80%. So this is my output. Simulation results at time t1. The temperature is 27 degrees Celsius and humidity is 80. So after I use the knob of the sensor to increase the temperature, the same is detected by the virtual terminal. So simulation result after some time, so T1 plus 1, the temperature has shown an increase in temperature, that is 28.4 degrees Celsius, and humidity has also increased to 80.3%. So this output also shows the successful working of temperature sensor with the Arduino, because the increase or the decrease has been detected by the Arduino. Third is interfacing the relay to the Arduino. So Arduino Uno along with a lamp and a voltage space is used in the workspace. In this case, relay is used to control the lamp. High and low values are sent to the relay after every 5 seconds so that the lamp turns on and off after every 1 second. So this is my connection as seen. This is my pin 1, pin 2 and pin 3. Now for lamp on, I can see that pin 1 is connected to pin 3. Hence this circuitry is complete and the lamp gets the voltage to conduct. As a result, the lamp is turned on. Whereas for the next case, after 1 second, as I said, it switches from pin 1 to pin 3, and then after 1 second pin 2 to pin 3. So this is after 1 second. So pin 2 and pin 3 is connected. This shows that the circuit is not complete. As a result, there is no path for the voltage to flow to the lamp. Hence, the lamp is turned off. So we can see that the relay is working successfully in order to turning on and off the lamp with the Arduino. Fourth is interfacing both temperature sensor and the motor to the Arduino. Now here in the code I have used the rule as only when the humidity rises to above 75%, then only my motor will turn on. If it is less than 75%, then my motor is turned off. So here when I increase the temperature to above 75% using the temperature sensor knob, and as I can see that the humidity is 79.9%, that is, it is above 75%. Hence, the motor is turned on as seen here in the workspace. Similarly, when I use the decreasing knob and decrease the temperature, the humidity has decreased below 75%, that is 74.9, and my motor has turned off. This also shows the successful working of temperature sensor and the motor with the Arduino. Hence, coming to the final interfacing of the entire sensor, where all the sensors and the outputs are used in a one work layout. So I have my PIR sensor and the temperature sensor and the output, the lamps and the fan together. So this is when the person has entered the room, that is the logic state has toggled from 0 to 1, indicating the person has entered. Hence, the lamp and fan has turned on as seen. In the second case, when the person is leaving the room, the logic state has turned to 0, indicating that person has left the room. Hence, the lamp and the fan is turned off. So that was my simulation part. Coming to the hardware, this was the final hardware of the project. This is my PIR sensor and this is my IR LED transmitter. This is again the PIR sensor, which is the inside of the hardware. This is my relay module. This is the DHT11 temperature sensor, and of course this is my Arduino Uno microcontroller. These are the connections made. Now, these are the output graphs. For all the succeeding output graphs, the experiment was a person was made to enter the room at the 3rd minute and the person left the room at the 5th minute. So all the graphs will be seen accordingly. This is the plot of PIR sensor response in time. So at the 3rd minute when the person is entering the room, we show it is seen in the graph that there is a change in its trigger level. And when at the 5th minute, when the person is leaving the room, it is again showing there is a change in the trigger level and hence it is raised. Similarly, we have the plot of bulb response in time. At 3rd minute, when person is entering, the bulb is turned on and it remains on till the person is there in the room. That is from 3rd to 5th minute. At the 5th minute, when the person is leaving, it has gone down, indicating the bulb is turned off. Similarly, for plot of air conditioner response in time, it has turned on, remains on and goes off at the 5th minute. These are the air conditioner remote response, similar to previous ones. Now, the current temperature and the current humidity of that room during the 3rd and 5th minute has been recorded. So as seen, during the 3rd time, the temperature has increased because the AC or the fans are turned on, obviously. So the temperature has increased. At the 5th minute, when the person is leaving the room, the temperature has decreased because my AC and the fans are turned off. Similarly with the humidity graph, it shows an increase from 3rd to 5th and then it goes down. So this is coordinating my Arduino with the PIR sensor, showing that the bulb turns on when the person is entering the room. So when the PIR sensor at the entry of the room has been triggered or when it senses motion, the lamp turns on. Similarly, when the PIR sensor at the exit has been triggered, the lamp turns off. Same has been done for coordinating Arduino with the PIR sensor to turn on and off the AC. So, at the entry when the PIR sensor is triggered, the temperature is increased from 27 to 26 degrees Celsius as seen. Similarly, when the PIR sensor at the exit has been triggered, it shows that the AC has changed its value from 26 to 27 degrees Celsius. So this shows that the fan or the AC and the light work properly with the PIR sensor along with the Arduino. So this is coordinating both the lamp and the AC together. So when the PIR sensor detects a person entering the room, both the lamp and the ACs are turned on. Similarly, when the PIR sensor detects that the person is leaving the room, the lamp and the AC turned off. Coming to the Adafruit IO, this is my IoT software that I have used for the project. It is a cloud service. It connects it over to the internet where I can store and retrieve the data. It also allows various other options like adding switches, buttons, sensors, etc. So this is the result for an occupied room when someone is already there in the room. It shows that the lights and ACs are turned on and the current temperature and humidity is also displayed. So at the user level, I have the ability now to turn off or turn on of the lights or the ACs according to my needs. So as seen in this video, when the PIR sensor is triggered, all the lights and ACs are turned on. So as a user, if I want the AC to turn off, I can use this switch to turn it off. Similarly, for a vacant room when no one is present, this is the IoT output where the lights and ACs are turned off, and of course the humidity and temperature are again displayed. So again I have the ability to turn it on even if no one is present, and if I still want the room to be cool, I can turn on the AC. So this is the video. As the PIR sensor is triggered again, where at the exit of the person, it shows that the lights and ACs are turning off, and I can put the lights and ACs on if I want. So the EMI-EMC testing was done for this project, where immunity testing and emission testing was done. In immunity testing, the various RF energy transmission was conducted and it was determined if the system operates correctly. Whereas in emission testing, we have measured the RF emissions for both radiated and conducted to determine if the emission levels do not exceed the limit. And after all this testing, I have received this certificate showing the successful completion of EMC compliance test for this project with my model name. So this is the certificate given to me by the company. Yeah, coming to the conclusion, of course, this project is energy efficient. It is easy to install. It is wireless and IoT enabled. Coming to the cost, the calculations have shown that the cost of the system has been decreased by 1/10 of the other installation costing. Future work we can in this project can be extended by taking consideration of the brightness in and around the room. Like if it is sunny, then we can decrease the intensity of the lamp, or if it is cloudy, we can decrease the temperature or increase the temperature of the AC. So that is taking in consideration the weather reports of the uh, area around us. So that will be our future work. So yeah, that's the end of the presentation. Thank you.